Welcome to Module 1, AI Architecture for Agent Builders. Now, before we start building agents that chew through spreadsheets and spit out clean commentary, I want to show you how the engine works under the hood. Most people use AI like a microwave. Push a button and pray something warm comes out. But if you're going to build reliable finance agents, you can't treat a jet engine like a microwave. You don't need a PhD, but you do need to understand how this thing reasons, where it's strong, and where it will absolutely fall apart if you let it. So in this module, we're diving into the mechanics that matter. How models read your input, how they hold information in memory, how they build meaning, how they plan steps, and where numbers go to die if you don't put guardrails in place. Let's get into it. How models reason, the 5 concepts you must understand. Tokens are AI's building blocks. Context windows are the working memory. Embeddings are the meaning map. Multi-step reasoning equals planning. Numeric reliability, that's where you want to proceed with caution. Let's start with tokens, the atomic building blocks of everything the AI reads and writes. You can think of a token as basically a tiny chunk of text. A few characters, a word, part of a word, whatever the model splits text into. If you hand the model a 40-page investment policy, it doesn't think, oh cool, a document. It thinks, 12,000 tiny Lego pieces I now have to assemble into meaning. This matters because agents don't get infinite building blocks. They get a quota. And once they're out of space, the model starts dropping information like a stressed analyst dropping footnotes at 11:59 p.m. So the takeaway? The more text you shove into an agent, the more careful you have to be. Long policies, giant CSVs, multi-tab spreadsheets, they eat tokens for breakfast. Next up, the context window. If tokens are Lego pieces, the context window is the size of the table you're allowed to build on. A context window is the AI's working memory. Everything it can hold in its head at once. If you give it too much, the model has no choice but to erase something to make space for something new. Just like when your whiteboard gets full and you start wiping off the part you think you don't need anymore. This is why your agent might understand your cost center mapping at the beginning of a conversation and then mysteriously forget it 10 minutes later. The rule? Don't overwhelm your agent. Structure your inputs and give it only what it needs. Where tokens give the AI text, embeddings give the AI meaning. Think of embeddings as the blueprint that tells the model which Lego blocks belong together. The AI converts text into vectors, basically math. This math tells the model things like, this section is about FX exposure. This paragraph belongs to cash pooling rules. This sentence matches your investment policy. Embeddings are what power RAG, Retrieval Augmented Generation, which is a fancy way of saying, don't guess, go look it up. This is crucial in finance because policies aren't optional. You can't have an agent freestyle an answer to a SOX-related question. When you use chat mode, the AI tries to give you an answer. When you use an agent, the AI tries to give you a plan. This is the single biggest difference between prompting and building agents. Multi-step reasoning means the model isn't just producing text. It's sequencing steps, it's analyzing inputs, checking rules, generating outputs, and formatting results. It's the difference between asking an intern for commentary and asking a senior analyst to walk you through every assumption, driver, and variance. Agents perform better because they break the problem down before answering. So here's something that might hurt your soul a little bit. LLMs are not calculators. They don't calculate numbers, they predict numbers. This is why you'll sometimes see a model rewrite your totals or round randomly. So when building an agent for finance, ground every number in the input file. Explicitly tell the agent never to invent numbers. Force it to reference the data provided. If you don't, you'll get numbers that sound right, the same way gym bros estimate their protein intake, confidently and completely wrong. Chat mode is like asking an intern for one slide. Maybe they'll get it right. Maybe they'll go rogue and use Comic Sans. Who knows? An agent is a role with rules and responsibilities. It has structure. It has memory. It can take action, and it behaves consistently across different inputs. This is what allows us to build true finance automation. Consistency, reliability, structure. One of the superpowers of agentic AI is tool use. This is what allows your agent to do things like read an Excel file, pull a range of cells, classify variances, generate structured commentary, and then output a clean markdown table. Memory is a second superpower. The agent can store preferences, formats, and context over longer workflows. Together, tools and memory turn an AI agent into a workflow. If you ever use a prompt that worked great until the next dataset completely broke it, you already know why agents matter. Prompts are fragile, but agents are structured. When your inputs change, new cost centers, new regions, new naming conventions, agents follow rules instead of vibes. RAG stands for Retrieval Augmented Generation. It's the AI equivalent of saying, don't guess, go look it up. This is crucial for things like treasury policies, investment limits, revenue recognition rules, close checklists, and delegation of authority. Without RAG, the model will bluff. With RAG, it cites sources. Large policies need to be broken into smaller labeled chunks. Otherwise, embeddings get muddy and the model gets confused. Trying to feed a 40-page policy as one block is like asking a new hire to memorize GAP over a weekend. They'll smile, nod, and get everything wrong. AI agents don't usually fail because the tech is bad. They fail because the inputs are unclear or the rules are contradictory. If your policy has two different thresholds for approval, guess what the model does? It picks one. Or worse, it averages them. If you're missing data, the model will try to fill in the blanks like a kid guessing on multiple choice. And the overconfidence, it's legendary. AI will tell you a completely wrong answer with the confidence of a consultant on a day rate. So what do? We fix this with guardrails. We tell the AI, if you're unsure, ask. Never invent numbers. Always cite data or policy. If information's missing, ask for it. Once agents operate with these rules, reliability jumps massively.